Be sure to watch the previous video to understand the concepts not covered in this one. In this lesson, we will learn how to spawn a player prefab, as well as implementing player movement and rotation. To keep things simple and avoid unnecessary complexity, we will not be using a rigid body. But before we jump into the tutorial, I need to explain some fundamental concepts first. Previously, when working on single-player games with mono behavior, we used the instantiate method from the Unity Engine namespace to place new game objects into our scene. Now that we're developing a multiplayer game, we encounter an issue. The instantiate method only creates the game object on the server, not on the clients. To ensure the game object is also created on all clients after being instantiated on the server, we need to use the spawn method from the Unity.Netcode namespace. Note that only the server can spawn network objects. In addition to the spawn method from the Unity.Netcode namespace, we also have the spawn as player object method, which is specifically used to spawn player prefabs. Before I explain further, keep in mind that we can send information in RPCs using method parameters, just like how the server is sending the integer value of 100 here. In a similar way, we will be sending the client ID from a client to the server. As you've noticed, the spawn as player object method takes a client ID parameter. Let's break down what client ID is and why it's important. In Netcode for GameObjects, the server is always assigned a client ID of 0. When clients connect to the server, they are each assigned a unique client ID, starting at 1 for the first client, 2 for the next, and so on. This ID helps distinguish each client in the network, allowing the server to identify and manage their connections individually. We can get the client ID of the client connected to the server by using the networkmanager.singleton.local client ID property. You can get the server's client ID using the networkmanager.serverClientID property. Note that this value is always 0 as the server's client ID is reserved for the server itself. The client ID parameter in the spawn as player object method assigns ownership of the player object to a specific client. This ownership enables the use of the isLocalPlayer boolean, which ensures that movement and rotation code is executed only for the local client that owns the object. In simpler terms, with 100 player objects in the scene, each running the same script shown below, a client, example client 1, can only control its own player object. This is because the isLocalPlayer boolean will be true only for the player object spawned with client 1's local client ID. For all other player objects, isLocalPlayer will be false, ensuring that client 1 can only control its own player and not the others. This setup ensures that each client can only control its own player object. Here is an example where a button sends a client's ID, example client 1, to the server. The server then spawns a player object for that client, using the client's local ID, which sets the isLocalPlayer boolean to true for scripts on that object, ensuring that only the respective client can control its own player. Note that prefabs need to be assigned inside a network prefab list for spawning to work. When we import netcode for GameObjects to our project, a default network prefab list is added to our assets folder. The prefab needs to be assigned inside the default network prefab list. And the network prefab list needs to be assigned in the network manager component. Also, the prefab itself will need to have a network object component for spawning to work. I need to explain something before we continue. In multiplayer, we essentially have multiple instances of the game running simultaneously, with each client and the server operating their own version of the game on their computers. The server and the client are each running their own game. So, when you move your character, the server makes the character on its game move, and it looks like the client's game character isn't moving, even though it is moving on the server. We need to make the position value sync from the server to the clients. There are two ways we can use to sync the transform values from the server to the clients. The first method is using RPCs in a script attached to the player. However, This approach is not recommended and is generally considered a poor solution to the problem. The second approach employs using the network transform component. The network transform component syncs the transform values we want from the server to all the clients. Here I have an empty GameObject player parent with a network transform that syncs the X and Y positions to the clients. Its child contains the sprite renderer and has another network transform to sync the Z-axis rotation. The Z-axis is always used to rotate 2D objects in top-down games. You have to make sure you are syncing the right values. Now the movement is being synced to the clients. Let's begin the tutorial. First, import the Text Mesh Pro essential resources as we will make 3 buttons. Now make a button. Change the canvas scaler component to use scale with screen size. 1920 for the X, and 1080 for the Y. Next, change the button's width to 300 and its height to 120. Rename the button to Start Server button. Change the button's text to Start Server as well. Make the font size 48 and make it bold. Select the button, then use the Ctrl-D shortcut to duplicate it. Change the name to Start Client button. Don't forget to change its text to Start Client as well. Now duplicate a button again so we get a third one. Change its name to Spawn Player button. Change its text to Spawn Player 2. Now select all your buttons by holding Ctrl, then anchor them by holding Shift-Alt before you press the top center anchor. Change the X position of one of the buttons to 400, the next -400, and keep the third one where it's already at. Now add an empty game object and rename it to Network Manager. Add the Network Manager component to it and select the Unity Transport. Now add another empty game object and rename it to Scripts. Create a script on it. I'll call mine Netcode example. Double tap the black region of the script so it opens in your IDE. Add the Unity.Netcode namespace, then change it from mono behavior to network behavior. You will notice a network object has been added to the script's game object. Now add the Unity Engine.UI namespace as we will make 3 button references. Name the button Start Server button, Start Client button, and Spawn Player button. Make listeners to their on-click events but keep them null for now. Now let's make the methods for the listeners. For the start server and start client methods, we will make it so we can only click the button for one of them once. I'll also ensure that the spawn button becomes clickable as soon as the client starts. Now let's start the server and client when these buttons are clicked. Add a network object reference to the script. We will instantiate then spawn the player prefab in the spawn player method. Let's correct the listeners now. We have a parameter for the third one, so we will use a lambda expression. We need to convert the spawn player method to a server RPC, as the client cannot spawn anything. Don't forget to add an RPC suffix. And correct the name for the listener. Lastly, we need to add these two things because we will use the update method for input handling, and it's better for the update method to have a target frame rate when using netcode. I made a mistake, put this in the start client method. Now then, we are going to import a package from the Unity Asset Store. Let's open up the Asset Store from Unity. Search for Joystick Pack. Add it to your assets and import it to Unity. I have already downloaded it, so I can import it directly. Look for the joystick script. We need to make the input inside it public so we can use it later to rotate our player. Don't forget to save the script. Now add a fixed joystick prefab to your canvas. Rename it to movement joystick. Make sure there are no spaces after the last letter. Then duplicate it and make another fixed joystick and rename it to rotation joystick. Make sure there are no spaces after the last letter. Change the X position of the rotation 1 to 1700 and the movement 1 to 200. Now let's make our player. Make an empty game object. Rename it to player. With the player object selected, right-click and make another empty game object, then rename it to body. Add the sprite renderer component to the body. Select whatever sprite you want for the body, we will make eyes for it later. Our player object is too small, let's make it bigger. If the player isn't appearing in your game view, reset its transform component values. Make sure the body is at 0 for the Y and 0 for the X as well. Now with the body selected, right-click and make another empty game object and rename it to eye. Add a sprite renderer to it, then change the color to black and use a sprite suitable for the eye shape. Let's move it to 100 for the X and Y so these weird things don't appear on the player while we try to resize the eyes. Put the eyes close to the top edge of the player. Duplicate the eye with Ctrl D to make another. Select both the eyes while holding Ctrl and change their sort layer to 1. Add a script to the player, I will name mine player script. Since our player is at 100 for both X and Y, we need to make it spawn in the middle of the game view tab. So let's set its position and rotation to 0 in the spawn method. Now open the player script and use the unity.netcode namespace, then change the class to inherit from network behavior. Add the two joystick references. We will use an on-network spawn method instead of a start method. Let's use GameObject.find to look for the joysticks we made previously in the scene. Make sure you use the same exact name they have in the scene. Let's make it so the code below the if statement doesn't execute if is local player isn't true. Make a vector 3 that will hold our movement input from the joysticks. Let's also make a method that will use this movement input to do stuff. Now let's make it a server RPC, as we only want the server to be moving our player. Don't forget the RPC suffix. Let's normalize the vector 3 input first before we use it inside the translate method. We need to use network manager.serverTime.fixed delta time instead of time.delta time because it is a multiplayer game, not a single player game. Let's make a speed variable and set it to 4. We will do the same for rotation now. Rotation requires that input variable we made public before. We need to multiply the X input by -1 because moving the joystick leftward makes the player look to the right and moving it rightward makes the player look to the left, and we want to switch this the other way around. Let's make a method for rotation as well. It will take the target angle, so let's make a float parameter. Let's convert it to an RPC because we only want the server rotating the player. Don't forget the RPC suffix. Ensure that no rotation occurs when the angle is set to 0. The body rotates on the z-axis. Let's make a reference to the body's transform so we can rotate it in the rotation RPC. Since the body exists on the prefab, we can assign it in the inspector instead of having to use transform.find. Make sure the prefab is assigned inside the default network prefab list and that the network prefab list is assigned inside the network manager. Let's add the right GameObjects to the right slots for our netcode example script as well. Also make the dead zone 0.3 and enable snap X and Y on both the fixed joysticks. Add a network transform on the player that syncs only the X and Y positions. Then add another network transform on the body that only syncs the Z rotation. Apply the new changes to the prefab. Now save the scene so we can start building. Make sure you change to a windowed screen 480 for X and Y in resolution and presentation in player settings before you build it like we did in the previous video. Make 3 instances of the game. One of them should be the server and the other two clients. There is some slight lag. But don't worry about it. That is because the target frame rate has been changed to 60 in the netcode example script. Now then, I want to show you that this is local player boolean can be written in a different way as well. Thanks for watching.